Alright guys, so I've been sitting on this project for a few months now and I think it's finally time to build it. The goal is an autonomous vehicle that can sweep the yard, mostly for rocks, and the best thing is pet waste. I'll be using Onshape for most of this build, and what I designed here was the motor that I'm going to be using, which is a geared 300 RPM motor. This is the basic design that I came up with, and it allows me to position the motor in or out and properly align the tracks. I wanted to create just a simple test rig that I can test all of my components over on my other workbench. The components were stuff I just had laying around. It was some drive belts from a pool cleaner, a couple of geared motors like I mentioned before, 300 RPMs, a piece of 20mm extrusion, and some basic hardware to hold it all together. You can see how that motor tips back and forth, and I designed the bracket on purpose like this so that the motor sits below the bracket and actually squeezes down and secures the motor while allowing maximum adjustability. Because I'm using extrusion on this project, I'm using what's called T-nuts, and what I'm doing is basically making sure that each side has contact and is pulling that bracket down equally, otherwise you risk everything coming apart. With everything mounted, I'm going to start securing one side of the wheel, and then I can start tensioning the other side, making sure that the track is in alignment when tightening all the motors down. I'm over at my other workbench and I'm starting to test the motors, and right away I'm finding out that the belt doesn't really want to stay on the rubber tires, so I think I'm going to have to redesign it. This is the part that I settled on, and you can see it has a guide for the track to go in, and then it also has cogs to help grip the belt. After getting the wheel printed out and getting everything put back together, I started to notice one major flaw with the design, and that was the wheel is depending on the axle shaft of the motor for all of the stress and strain on the belt. So I think that we need to redistribute the load, and basically what I came up with is using a axle shaft and two bearings to support that load. And I kind of had a couple of reiterations with this, and one was with the gear on the outside, but you can see that the clearance on the motor to the wheel is too close. I thought about putting the gear on top of the wheel, but ultimately what I settled on was, just like the drawing, spreading the load onto the bearings and that axle shaft, and I was able to incorporate the gear into the wheel. This is the basic design of the frame that I came up with, and you can see I placed all the wheels and motors on there, and I was trying out something new with Onshape. They have augmented reality, and it was kind of finicky, but I was able to kind of view it in real time. Cue up the montage. After my speed controllers showed up, I decided that I was going to wire them, and I used DuPont connectors so that I could swap the motor direction easily without having to resolder the connections. I like using these cheap DC motor controllers that run off of PWM signals. They're rated for 20 amps and should be able to drive the motors that I have really easily. So I knew I was going to at least have one motor that was running backwards, and you can see I can just unplug that DuPont connector and flip it around, plug it back in, and then the motor's going to be going in the correct direction. So after getting the project all wired up, I wanted to kind of button everything up. So I grabbed these Velcro cable ties and I'm able to just strap everything down to the extrusions, get it up out of the way so that I can drive it around and test it. Alright, so buttoning everything up was pretty straightforward. Got it up out of the way so I don't run it over. Then I'm going to do some testing on the ground. Everything was pretty straightforward, just moving basic controls, making sure everything worked before I took it outside. After taking it outside and trying to climb this small hill, I ran into some pretty substantial issues. One of the issues is I don't have enough ground clearance to climb this small hill. And also, the motors are really underpowered, so I can't climb it either. Dirt was getting pulled into the wheels, and it was causing the gears to get bound up. And with the lack of motor power, that didn't help either. I also found out that the dirt likes to get sucked into the tracks and then throw the track off, which I'm fixing here. So in the future video, I'll be adding more motors, changing the wheel configuration, and adding the brush mechanism. I hope you like and subscribe and follow along for more.